students, myself Dr. Bharati Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. We have started our syllabus related to TYBSc solid state physics, and in that we have started our chapter number 2, that is X-ray diffraction and other characterization techniques. We have covered few of the points related to it, such as Bragg's law, and today we are going to solve few of the examples based on it. So let's try to solve few of the examples based on Bragg's law and chapter number 1. Our first example is a monochromatic beam of X-ray having wavelength 1.2 angstrom is incident on a crystal. The first order maxima of the reflected X-rays are obtained at an angle of 7 degree. Calculate the glancing angle for the second order reflection. So what is our example? A monochromatic beam of X-ray having wavelength 1.2 angstrom. Wavelength of beam of X-ray is given. It is given as 1.2 angstrom. Is incident on a crystal. The first order maxima of reflected X-ray are obtained at an angle of 7 degree. First order maxima obtained at angle of 7 degree is the glancing angle for first order maxima. Calculate the glancing angle for second order reflection. It means that we have to consider two orders, first order and second order. So we know that Bragg's law is given as Bragg's law. What is Bragg's law? It is given as 2d sine theta is equal to n lambda, where n is, what is d? D is the interplanar distance, theta is the glancing angle, then n is the order and lambda is the wavelength of X-ray used. Now here two orders are given, first order and second order. It means that we have to write the formula for first order. Suppose for first order I am considering it as theta 1, means for first order n value will be 1, and consider theta as theta 1. So our formula for first order becomes 2d sine theta 1 is equal to lambda. Now we have to calculate the glancing angle for second order reflection. For second order reflection, it means that for second order reflection our formula becomes Bragg's law, sine theta 2 is equal to, now for second order n is equal to 2. For second order n is equal to 2. So substitute here, and theta, suppose theta is here, theta is equal to theta 2. So our formula for second order becomes 2d sine theta 2 is equal to twice of lambda. This is the formula for second order reflection. This is for first order reflection. For first order reflection, and this is for second order. And what we have to calculate? We have to calculate the glancing angle for second order. Means glancing angle for first order is given, theta 1 is given, and it is given as 7 degree, and we have to calculate theta 2. What is the value of theta 2? This is our example. So what we have to do? We have to take the ratio of this to this. So we will have 2d sine theta 1 divided by, divide equation 1 by equation 2 is equal to lambda, divided by 2d sine theta 2 divided by twice of lambda. So what you will get here, 2d will get cancelled. It means that sin theta 1 upon sin theta 2 comes out as 1 upon 2. So here theta 1 is given and we will have to calculate the value of theta 2. So we will simplify it and rewrite as sin theta 2 is equal to, this term will go here, sin theta 2 is equal to 2 into sin theta 1. 2 into sin theta 1. So substitute the value of sin theta 1. Theta 1 is given as 7 degree. As theta 1 is given as 7 degree. Substitute the value of 7 degree in this equation. So sin theta 2 is equal to 2 into sin of 7 degree. So what is the value of sin of 7 degree? Sin of 7 degree is 0.2 into 0.1219 and take its product. Its product come out as 0.2438. This is the value of sin of theta 2. This is the value of sin of theta 2. Let's revise. Example is given as a monochromatic beam of X-ray having wavelength 1.2 angstrom is incident on a crystal. The first order maxima is given and glancing angle for first order is given as 7 degree, and they have asked us to calculate the second order reflection, that is glancing angle for second order reflection, that is theta 2. In order to calculate this, we have rewrite the Bragg's law for first order and for second order. For first order it comes out as 2d sin theta is equal to n lambda. For first order n is equal to 1 and theta is equal to theta 1. We have obtained this equation. For second order we have substituted here theta value as theta 2 and n as 2 and we have obtained this equation. Now we have taken the ratio of these two equations and from that we have obtained the sin theta 2 value as 0.2438. But we have to calculate the value of theta 2. Hence, I will write here, as we have to calculate the value of theta 2. Hence, theta 2 is equal to sin inverse of 0.2438. Theta 2 is equal to sin inverse of 0.2438, and if we calculate this or when we obtain the sin inverse of this value 2438, it comes out as 14.11 degree. Therefore, value of theta 2, that is the glancing angle for second order reflection, is obtained or found to be 14.11 degree. What is the glancing angle for second order reflection is found to be 14.11 degree. So this is our value of theta 2, that is glancing angle for second order reflection, 14.11 degree. Students, let's try to solve one more example based on crystallography. So our example is the distance between 1 planes in a face-centered cubic crystal is 2 angstrom. Determine the lattice parameter and atomic diameter. This is the example. The distance between 1 plane in face-centered cubic crystal is given as 2 angstrom. Distance between planes means that value is interplanar distance. Interplanar distance D is given as 2 angstrom. And the planes are given. Planes are given means these are HKL planes. HKL planes are given as 1, 1, 1. It means that H value is equal to 1, K value is equal to 1 and L value is equal to 1. Now, they have asked us to determine the lattice parameter. Lattice parameter is nothing but the value of A. What is the value of A? Lattice parameter. And atomic diameter. Atomic diameter. What is the atomic diameter? Suppose I am using a notation as D, capital D. Atomic diameter we have to calculate. What is the value of A? So, in order to solve this example, we have to use the relation between A and D. What is the relation between A and D? We know that D is equal to A upon square root of H square plus K square plus L square. Because we have to calculate the value of A and D is given. HKL planes are also given. So, here A will become D into square root of H square plus K square plus L square. So, value of D is given as 2 angstrom into bracket H square means 1 square plus K square means 1 square plus L square means 1 square because their values are given for 1, 1, 1 plane. So, we have obtained the value of A, that is lattice parameter, as 2 into root 1 square is equal to 1 plus 1 square is equal to 1 plus 1 square is equal to 1. So, its value comes out as 2 into root 3 is the value of A. As D is given in angstrom unit, here you have to write the unit as angstrom. So this is the value of lattice parameter A. Now they have asked us to determine the atomic radius, diameter. Atomic diameter. We know that diameter is the twice of radius, as diameter D is equal to twice of R. R means radius of an atom. Here R is radius of an atom. But radius is not given. That's why we have to calculate the radius. Then here structure is given as face centered cube. And we know that what is the formula of radius for face centered cube. So we will write that formula in case of FCC. In case of face centered cubic crystal, R is given as root 2 upon 4 into A. What is the formula? R is equal to root 2 by 4 into A. And we have to calculate the diameter. And diameter D is equal to twice of R. So substitute the value of R here. R is equal to root 2 by 4 into A. But just now we have calculated the value of A also. So substitute that value 2 into root 2 upon 4 into A value is we have calculated as 2 into root 3. 2 1s are 2, 2 2s are 4. So here root 6 is the value of D. When we calculate this value of root 6, then this value comes out as 2.45 angstrom. So we have calculated the diameter by calculating the radius of FCC crystal. So In this example, we have initially used the formula D is equal to A upon square root of H square plus K square plus L square. As D and HKL values are given, we have calculated A. Then we have to find out atomic diameter. We know that diameter is twice of radius, but in order to calculate the radius, we have used the information that crystal structure is FCC. So we have written the formula for FCC. R is equal to root 2 by 4 into A is the formula of radius for FCC, and we have substituted this formula in diameter, and we have obtained the value of D. D as 2.45 angstrom. Thus today we have covered two of the examples based on crystallography. In next lecture we will try to solve few more examples based on it. Thank you.